All right, what's up, guys? Today I'm going to be going over the semester 1 exam review. I'm going to be doing a lot of the important questions as well as giving you guys important hints as to what might be on the semester exam. So just watch out, listen, make sure you're listening to what I'm saying and paying attention to things I emphasize in the problems. So the main thing that this test is going to be about key features. So I'm just going to write that up here. Key features. Key features of functions, because that's what we've been talking about. And some of the key features involve domain and range, which is this first unit right here. It also involves finding x-intercepts and finding minimums or maximums, like all this stuff. Seeing wherever two functions intersect and knowing that that's the solution and all that type of stuff. That is going to be the main thing that's on the test. And since you have a calculator, you'll be able to graph a lot of these functions and just notice the key differences. But anyways, we'll start right here. So we're talking about domain and range. And if we remember, domain is going to be the furthest point on the left, and from the left all the way to the right. So we go from left to right. For range, we're going to be talking about the points lowest to highest. So range is y values, domain is x values. Range goes up and down, domain is left and right. So when we look at this graph right here, we're thinking about the furthest point that is on the left and the furthest point on the right. So right here, I notice that the function is going forever to the left, which is kind of like negative infinity. And it goes forever to the right, which is infinity. So we got parentheses, negative infinity, comma infinity. And it's interval notation. So that's the one that has parentheses and brackets, and that's why we wrote it like that. Now for inequality notation, it's going to be very similar. But instead of parentheses and brackets, I'm using inequalities naturally. So it's important to keep in mind that parentheses line up with the less than or equal to signs. These signs right here. And they would have been brackets they would have been less than or equal to signs if I had put brackets in the interval notation. But the reason I put parentheses is because infinity is something that goes on forever. I can't ever reach it. So how could I ever reach it? Or how can I put a bracket if I don't reach it? Bracket means I reach that value. And we're going to see some examples of that later. Now for set notation, that's the one that looks like this. X such that x is a part of all real numbers. So those curly brackets define a set. And a set can be anything. But specifically, we're talking about x values, which is normally domain. And that little line specifically means we're talking about all real numbers, which is all the numbers pretty much. Now for range, we're talking about the lowest point. Looks like it goes down forever, which is negative infinity. And it goes all the way up to here, which is comma 3. So we could never reach infinity, but we could reach 3. We do reach 3. We have a point at 3, so that is why we put a bracket. Similarly, we could just do negative infinity is less than y, which is less than or equal to 3. The reason why we do a little equal to symbol underneath that second inequality is because of the bracket. Finally, we got y such that y is a part of all real numbers. This is just how we start or how we set up these types of domain and ranges. I don't leave too much space for this one, but it's very similar. We just want to write the beginning of the set notation and then add the little inequality next to it with a comma. So now let's take a look at this next example. So we're talking about the furthest point on the left. For domain, furthest point on the left, which is right here. Looks like that lines up with -6, and the furthest point on the right is going to be 2. Both brackets because we have a point there. We reached it. For inequality, we have -6 is less than or equal to x, which is less than or equal to 2. The less than or equal to corresponds with the bracket. And then finally, we have the set of all x such that x is a part of all real numbers. But specifically, we want those values that are going to be in between -6 and 2. So that's why we have to write that little extra part. For y values, the lowest point is going to be right here at -4. The highest point is going to be at 8. And we reach a point there also. So now we got -4 less than or equal to y, which is less than or equal to 8. And we set it up very similarly. So you do y such that y is a part of all real numbers, specifically those from -4 all the way to 8. Okay, now we're talking about this exponential function. An exponential function is something that grows in this manner. It's going to be important to know for the test. Okay, so we have that exponential function. It looks like we have an asymptote down here, and then it exponentially grows up here. But whenever we're talking about domain and range, okay, what it looks like, it goes this way forever. And it might not seem like it, but it does go to the right forever. So that just means -infinity to infinity. And of course, we can't reach either infinity, so we have to put a parentheses. Less than x is less than infinity, like we wrote for the first example. And then finally, we got x such that x is a part of all real numbers. And now we're talking about the lowest point. It seems like the lowest point is going to be at around this value, which looks like it's going to be 5. And then the highest value is going to go up forever, so it's going to be infinity. Now we know there's a parentheses at infinity. We can't reach infinity. But for 5, there's also going to be a parentheses. If we were to zoom into it with a calculator, we would see that it hovers right above the 5. We're going to see that it never actually touches it, but it gets super close to it. So we could say it is at 5, but not including 5. From here, we could write 5 is less than y, which is less than infinity. And we could do y such that y is a part of all real numbers, including those from 5, from y to infinity. Hopefully domain and range is clear now. We've been going over this for pretty much, or you guys have probably seen this in Algebra 1. And we've been going over it every single unit. So hopefully it's stuck a little bit. But anyways, we're going to continue with inverses. So if you guys remember what an inverse is, it is basically something that goes from x to y and y to x. So the values switch. In the case of points, if before we had an x comma y, now we have a y comma x. And so if our set is that 1 comma 4, 0 comma 8, -3 comma 9, now we have 4 comma 1, then 8 comma 0, and then 9 comma -3. The values flip. It doesn't change signs or anything, it just flips. Now for inverse, it's very similar. We can rewrite f of x as y, because we know that f of x is equal to y. And then if we rewrite it like this, we just want to make sure that we could flip it the same exact way. So we got x is equal to -6 minus 4 times y. And when we have this, we want to make sure everything is that only the y is on the same side, or that the y is all by itself. So I see this -6, so I want to move it over to the other side. So we got x plus 6 is going to be equal to -4y. I'll actually rewrite it over here because I'm running out of space. Last step is to divide by -4. So we get an answer of y is equal to -1 over 4x minus 3 over 2. It simplifies to 3 over 2. That is the inverse. Next, we're going to solve systems of equations. Now, you're for sure going to get questions like this, and there's different ways to solve this question. I'm going to show you 3 methods right now. So the first way is you're going to use something called substitution. And substitution means we have one of the equations that is equal to a term. We have a variable that is equal to something that we understand. So for example, we have y is equal to x minus 3. Y is the same thing as x minus 3. Meaning whenever we see a y, we just want to replace it. So we got -4x, then we got plus y, which we know is equal to x minus 3. So we could just replace it with that. And then that is equal to -9. I wrote the first equation down right here. And now here, since everything is in terms of x, then we could just solve for x. So negative 4x plus x, that means we have negative 3x. If we add the 3 to both sides, we just have a negative 6 now. Divide the negative 3 on both sides. We get an x equals a positive 2. Now the way to solve for the remaining variable y is we just want to plug this into any of the equations. In this case, I'm going to plug x equals 2 into the second equation. This one right here. Because now we know x is equal to 2. So we just do that simple calculation. We get y is equal to negative 1. Next thing, we have elimination. So elimination, we want to multiply one of the equations by a number, a coefficient, so that whenever we add them up, something will cancel out. Now I noticed this 2y, and it's a positive 2y, and now if only we had a negative 2y on the other side, it would cancel out, but we don't have a negative 2y. We just have a negative y, meaning we have to multiply by 2. So doing that, let me just write the first equation real quick. It's equal to 10. We get 2x, because 2 times x, then the negative 2y, and then 13 times 2 is 26. We did these operations pretty much. Now we add up all this. We combine for 6x's. This cancels out. So we have 36. Now that everything is just in terms of x, we only have x variables. All we have to do is divide by 6. Get x is equal to 36 divided by 6, which is 6. And now it's the same process. We just want to plug in that x equals 6 into one of the equations. I'm going to do the second one because it looks pretty simple. But yeah, it's the same thing. So we want to add the y, subtract the 13, subtract the 13. So that means we got y is equal to negative 7 when we do negative 13 plus 6. So that's our answer. Now, a quick hint I'll give you. You could just try graphing this. Whoops. You don't have to do this whole crazy method every time. You could first try graphing. Because when you graph, you're going to see two lines. Let's say it's going to look something like this. Something like this, and then something like this. The main thing you want to focus on is that intersection point. That is going to be the key to solving your answer if you have a graphing calculator on the test, which you will have. Now, next thing, we want to use matrices to solve systems below. So this is a matter of remembering how to plug it into the calculator. So for example, we have that big matrix up here. So you're going to rewrite it all into your calculator. If you don't remember, the steps are going to be right here on the left. So yeah, you just want to put in all those numbers into the matrix. And then the key thing to do is put a negative 1 at the top right. And you're going to multiply that with the second matrix, the skinny one. And from there, you should get your answer. It's going to be an x, y, and z. I don't have a calculator on me, but you could do this with the TI Nspire, and you could get the answer for sure. I'll probably go over this during the day that you have the test as well. Now down here, you got 3x, and then 2y, then minus 7z. So all you got to do is fill in the matrix. We have a 1y. You have a single y, so you just want to do a 1. Close it, and remember that negative 1, and times that last matrix. All of this is going to be equal to your answer, whatever it is. So that is what you would plug in. All right, next thing, we're going to do absolute value functions. So absolute value functions are those two little lines, and it always makes things positive. It's always going to be positive. Now we can look at the transformations based on an equation. So let's look at this one. We have a plus 3. I'm going to do a little line like that. And then we have a little minus 7. And I'm going to do another little line like that. So that plus 3 is going to correspond to a shift of 3 units. And it's going to be to the left. Whenever we have a plus inside that absolute value, or it could be a parentheses, or it could be a square root, or whatever, it's going to be, if it's plus, it's going to be left. If it's minus, it's going to be right. Next, we have a minus 7, meaning it's just going to shift 7 down. So if it's on the outside, it's going to shift down if it's negative, shift up if it's positive. So now that we have that, maybe we could use this equation to see how the transformations will affect the shape of the graph. So first, I'm just establishing all of the transformations. So at negative 3 means it's going to shift 3 to the right because it's a negative 3. That plus 4 means it's going to shift 4 up. And then finally, that 2 means it has a slope of 2. Whoops. Slope of 2. Which means it vertically stretches. That means we kind of stretch it upwards like a rope. So that's why I write the word rope. Okay, so let's look at all of our transformations. So it shifts 3 to the right. So 1, 2, 3, 4 up. 1, 2, 3, 4. And it has a slope of 2, meaning it goes up 2, then 1 to the right. So it has that kind of shape. Something like that. And that's our function. That is how our equation is graphed with the transformations. Now, instead of just working with the graphs, let's see how we can work with algebraic functions. And now we just want to recall what the definition of an absolute value function is. So if we have absolute value of 9, that means it's going to be 9 spaces away from the number 0. Or if we're looking at a number 9, it's going to be 9 units away. Negative 3 is going to be 3 spaces away from the number line. Or it's anything turns from negative to positive. Now if we have x, that means x could have been 5, or it could also have been negative 5, because it is 5 spaces away from the number 0. And both 5 and negative 5 are 5 spaces away. And if we understand that question, we could also start to solve bigger absolute value functions so that we can, if we just treat it like an algebraic expression. So first we add the 5 on both sides. Then we divide by 2. So we got x minus 1 is equal to 3. Now from this point, if we have an absolute value expression equal to a positive number, that means we're going to have 2 answers. We're going to have x minus 1 is equal to that 3. Then we're also going to have x minus 1 is equal to that negative 3. Similar to question 14. We have a positive and a negative answer. Now from here, we just want to add the 1 on both sides. We're going to get 2 answers. X is equal to 4 for that first one. And then x is equal to negative 2 for that second one. Okay, for this one, we have minus 3 minus 3. And what we want to do is think about this for a little bit. So 1 minus 3 is negative 2. Now, if we think about it, this thing is always going to be positive. We know that absolute value expressions are always positive, but we're also saying that it's going to be equal to negative 2. So the contradiction here is, okay, so absolute value functions make things positive, but it's equal to negative 2. Well, that doesn't sound possible to me, so all we need to write is no solution. All you need to write. Because absolute value expressions do not make negative numbers. They make positive numbers. Always positive. And now, for sure, you're going to get a question like this on the test, so make sure you understand it. So it's going to be in this form. X minus target, absolute value of all that is equal to varies. So you want to have, okay, so we have a temperature of the wave pool at 6 Flags, and it can vary up to 4.5 degrees from the target temperature of 82 degrees Fahrenheit. So that means we got our expression, x minus target, which is telling us it's 82 degrees. That's going to be equal to the amount that it can vary, which is 4.5. Look at that. It says write the absolute value equation. That is our first answer. And now we need to solve for the max and mins. And the way that we solve that is we just do the same thing. It's equal to a positive number. So that means x minus 82 could have been 4.5. X minus 82 could have also have been negative 4.5. And when we add 82 to both sides, to both equations, we get two answers. The maximum and minimum temperatures of our pool. X is equal to 86.5 degrees Fahrenheit. X is equal to 77.5 degrees Fahrenheit. So the majority of these questions you could just graph, especially if you're given an expression, or if you're given this equation for number 11, or if you're given also the equation like a number 9. It's just a matter of graphing it if you have a calculator, which you will have. Our next questions, we got quadratic functions, quadratic equations, and that is anything that has an x squared term up there. And now, again, reminding you guys, there's going to be a lot of key feature questions. So as long as you understand how key features generally look like in all sorts of equations, then you should be fine. So vertex, that is like where we see a point on our graph. Here we see we have a vertex of negative 2, 0. So that is exactly what we'll write. We also notice that it's a minimum. It kind of looks like a valley, so we'll circle minimum, and it's going to be at y equals whatever the y value was, which is 0. Minimum is y equals 0. Zeros. It touches the x-axis at, coincidentally, the same place where we had a vertex. So we're going to have negative 2, 0. Find that the axis of symmetry, it's always going to be equal to the x value of the vertex. So we got x is equal to negative 2. Now, domain and range. So domain, it looks like it goes to the left and right forever. So that means we'll have a negative infinity all the way to infinity with parentheses. And now we're talking about lowest point and highest point. So lowest point is going to be what we already said, which is the minimum. So we have a 0, and then the highest point is going to be up forever, which is infinity. Keep in mind there's a bracket at 0 because we have a point at 0 right here. It goes up to infinity, and we can never reach infinity, so that's why we have parentheses. Okay, let's check out this next one. We got a vertex all the way up here. What does that look like? 1.5 and 4.5. Interesting numbers, but let's just roll with them. So it looks like a maximum now. It looks like a hill, like a mountain. And it's going to be at the y value of the vertex, which is y equals 4.5. We have two x-intercepts, two zeros. One's going to be at 0, 0. Another one is going to be at 3, 0. The axis of symmetry is the x value of the vertex, meaning we have x is equal to 1.5. Domain and range. Okay, domain, it goes to the left and right forever. So we have negative infinity is less than x is less than infinity. It goes down forever and reaches all up here, all the way up to that point. So negative infinity, because it goes down forever, less than, and then less than 4.5, which is the max. Keep in mind there's a little equal symbol underneath that inequality. So I wrote the domain and range differently for examples 19 and 20, but essentially they represent the same things for their own respective graphs. It's just a different way to write it. Okay, next thing. We're going to write down the equation in different forms. And I don't leave too much space to write this, but the main important thing is to keep these equations in mind. So we got y is equal to x minus h squared plus k. And I'm doing a little v for vertex form. Factored form is going to look like y, which is equal to x minus x1, x minus x2. Finally, the last equation, which I'll write here, hopefully you have space on your paper, is going to be standard, which is going to be y is equal to ax squared plus bx plus c. Okay, so you notice that all of these equations have the letter A. It's like, what the heck is that? Well, A is going to be rise over run squared. And our rise over run is always taken from our vertex. So rise, we go up 4, and then we go 2 to the right. So that means our rise is 4 over 2 squared. So we got 4 divided by 2 squared, which is 4 divided by 4, which is equal to 1. So we have A equals 1. I'll write it in blue, actually. Our vertex is just going to be -5, comma, -4, which is right here. Our x-intercepts are going to be -3, comma, 0 and -7, comma, 0. Right here. -7, comma, 0, -3, comma, 0. And our y-intercept, we don't know that yet. Maybe we'll figure it out with our forms. And the way that we figure out how to write our equation in different forms is we just use each open-ended equation. So let's see vertex form. Y equals a x minus h squared plus k. So we know what our a value is. It's just 1. So x minus h. H is actually going to be the x value of the vertex. In this case, it's -5. We wrote it up here. Now we're doing x minus -5. So that's just going to be +5 squared. And then plus k is just going to be the -4. And that's it. Factored form is very similar. We have y equals a, which is 1. Then we're going to do x plus 3, x plus 7. x1 and x2 are going to be our x-intercepts. So we have a -3. We would have done x minus -3, x minus -7, which is where the plus comes from. Finally, the last step is to FOIL. So we would have taken factored form and we would have FOILed it out. FOILed is multiplying like this with those lines. And I'm just going to skip a step so that I show you guys what the equation is. But if you FOIL correctly, then you should get this after combining like terms. 21. So x squared plus 10x plus 21. Last key thing, we're always going to have a y-intercept at 0, comma, whatever this last number is. This case, it was 21, so our y-intercept is at 0, comma, 21. Okay, so we just have a few more questions and then we're done. Let's just finish strong. So these look very similar to the other ones that we went over about absolute value. So let's write a quadratic equation that has been translated 2 to the right, 3 units down, and stretched by a factor of 2. And the key to solving these types of questions is to keep this vertex form in mind. So it said, okay, stretched by a factor of 2, which means 2 right there. Then it moves 2 to the right, which is going to be x minus 2. I'm going to do 2 to the right. And then it goes squared 3 units down, which is going to be -3. This -3 is that one. So this is our answer. Next thing, it says what is the vertex for the quadratic, and then it gives us the equation. So all we have to do is remember how it shifts. So this +12 means a -12 shift. This -20 means a 20 down. So the vertex is -12, -20. Next thing, we have these regression type questions where we're given some data. So a model rocketry club placed an altimeter on one of its rockets. Basically, it measures the heights after every certain amount of seconds. In this case, it looks like every second it measures the height. So an altimeter measures the height of an object above the ground. It shows the data. The table shows the data that the club members collected before it stopped transmitting a little over 9 seconds after the launch. So I scratched out these bottom questions because the main thing I want you to be able to get is the equation. And these are the steps right here to find the equation, which are pretty straightforward, I hope. But it's just going to be about using the TI Nspire list and spreadsheets program. You're going to put in all this data. At the very, very top, you're going to make sure you call the columns X and Y. It's going to look something like this. And from here, you're just going to do all the data, 1, 2, dot, dot, dot. It's going to be 0, 54, 179, dot, 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 dot. And then you're going to start here. Menu 416, do the X and Y, which is what you called your columns. Then enter, and then you should be able to see all the values of your equation. You're going to get an A, a B, and a C value. And that is going to be the way that you write the equation. You write it in ax squared plus bx plus c. So the reason I wrote this a little too is because you're going to for sure have at least 2 questions on this. And I'll go over this more in depth when you have to take the test. Now we're just going to go over these last few questions. So we got solving quadratic equations, which there were many different ways to solve. For example, we had box method or grouping method, which it doesn't really matter what you do. I'm going to do box real quick. So first thing is putting in that first thing in the box and then that last thing in the box. And then the key is to think of 2 numbers that multiply to negative 63, but add up to that negative 2 in the middle. So there's a few numbers that multiply to negative 63, but we should have a 7 and a negative 9 for our 2 factors. 7 times negative 9 is negative 63. 7 plus negative 9 is negative 2, which is what we want. So now we put in our factors in the box. And now we want to look at column by column and row by row to see what are our greatest common factors for each row. I look at this first one, x squared and 9x, that first column. You could divide both of them by an x. Second column, you could divide both of those numbers by a 7. The first row, divide them both by an x. And the second row, you could divide them both by a negative 9. So there's a negative in the front, meaning we have to divide out a negative. From here, we group our terms, giving us an answer of x minus 9, x plus 7 is equal to 0. And the way that we solve these types of questions is we just want to see what our x values would be if we equal each binomial to 0. So for example, we have x minus 9 is equal to 0, x plus 7 is equal to 0. So this inverts our answers in a way. So we'll get x is equal to 9 and negative 7. So this is going to be the same process that you're going to do pretty much for all these questions. Or you'll just be able to graph it. Maybe that's what you could do. Find the x-intercepts. So instead of having to do this box method every time, you could just graph it and see where the quadratic function has x-intercepts. You're going to be able to do this for a lot of these different types of questions. So I suggest try graphing almost every single question that you can to see what kind of information you could get really quickly. Last key point is we're going to have this quadratic function that might be important for you to remember. X equals negative b plus or minus the square root of b squared minus 4ac. All of that is divided by 2 times a. So that is going to be helpful if you want to solve it that way. But let's say you're given an equation like this. It's going to be very easy to set each of those terms to 0. 3x minus 8 is equal to 0. First one, you subtract 2 on both sides. So that means you have x is equal to negative 2. This one, we have a plus 8 plus 8. So that means we just are left with 3x is equal to 8. And we divide by 3. So we have an answer of x is equal to 8 plus 3. And that's pretty much it. That's the entire review, at least the ones that I thought were most important. But let's just recap some stuff real quick so that you have expectations of what is going to, you understand my expectations of what you should know for the exam. So it's going to be a lot of key features. You need to know what domain and range is, and you need to understand that it can be expressed in different ways. There's going to be several questions about this. You also are going to need to know what an exponential function is and how that is written algebraically. Next, you're going to get some questions about inverses and how to go from a set of points to the inverse of those set of points, as well as a function. You're going to get some solving systems of equations, either by just graphing or using matrices, or if you want, use substitution and elimination. Next, you are going to get a bit of transformation, not as much as other subjects, but it's good to know. So knowing how a function is transformed based on whatever is being added or subtracted or multiplied in the front, like here, we've got a 2, and that stretches it vertically. It's important to know what it means by stretching vertically. Also, you're going to get, I think, a few absolute value functions, but absolutely you're going to get one like the very bottom. Knowing how to write an absolute value equation for a real world scenario and solving for it, which you could also just graph. Also, you're going to have a lot of key feature questions just in general. It's helpful to know what are your vertexes, how to find your axis of symmetry. It's always the x value of the vertex, and so on. I want to focus too much on the different forms. It's not going to be a big emphasis. And finally, getting an equation from a graph from the transformations of a quadratic is going to be important for you to know. You're going to have 2 questions on quadratic regression, which is going to look like either a bunch of data or it might even just be 3 points that you need to find a regression for. And then finally, we're going to have a lot of solving quadratic equations, which you could do with box method, quadratic equation, or just by graphing. Now, hopefully this review is of help to you. As always, you could reach out to me and let me know if you have